Welcome back to Alexander's Adventures, and today we're doing a glove repair because the heated gloves that I got for the expedition had a broken wire in them. Right here you can see this wire is supposed to lead through this pass-through right here and go into the heating element in the front of the glove, and you can see I've got the glove turned inside out. The activation button is right here, and I'll show you how this all works and goes together with the working glove that I've got. But right now, the key element here is this thing is not a normal wire. If you've ever done wire repairs, you'd know. Let's see if I can give you a little bit of a view with this, with some light. Come on, okay. So these little wires right here, it's hard to see, but they are essentially not your typical wires. These things are made of carbon fiber. Now, not knowing what I was dealing with initially, I tried lighting them on fire to see if it was like a nylon coating or something like that. So I'm going to have to do a little bit of repair. I may cut the ends again and then re-terminate them. But this is like in a pinch. I don't have a lot of time. I'm actually leaving in 3 days. So this was all like, oh shoot, my gloves don't work and I have to fix them because I can't get a replacement, and anything else would have just been basically abandoning the gloves entirely. And I'm confident in my ability to repair things. It's just this is the first time I've ever done a set of of heated gloves. So I've got, not recommended, these crimpers, but they will have to do for today. And I got a set of crimping splices. The thing about these though is they're supposedly for 26 to 24 American wire gauge, which they ostensibly are. That's the splice that's on the inside of those heat shrink tubes. I'm not going to use those heat shrink tubes. I'm actually going to use a little bit of white heat shrink that I just had left over. And it's not going to get down to the small enough size for the wire, so I may actually end up putting something else in there to seal things up a little bit better. But the original splices this came with are these tiny brass splices. And matter of fact, this wire has 2 of them. I don't know why. But yeah, this is going to be a difficult task because carbon fiber wire you can't solder, obviously, so it has to be spliced together. Thankfully, I've already plugged this thing in, had the wires touched together, and tested everything, and it did indeed work. I wasn't able to put my hand in the glove at the time, so I don't know for certain that it actually got the entire heating element working again, but that's just one of those like, well, I'm just going to find out later kind of things. So let's see if we can get started. The first thing I'm going to do, because this is an extra long splice, I'm going to try chopping this guy in half so that it's a short enough length that I can work with it. I don't have my cutters handy, so I've got to use a pair of pliers. And half of doing work like this is sort of improvising with the tools that you have, because obviously I'm not able to take the time to go get the normal stuff. So this is just going to have to do essentially. Matter of fact, kind of thinking it might, well, if I can get this thing broken in half without destroying my desk or damaging anything. Yeah, okay, cool. So it's, the only problem here is once I've done this, I got to make sure that the opening yeah, okay, so it looks like it'll work. Now I got 2 tries. So, first things first, let's see if we can re-terminate. Yeah, I'm definitely going to have to re-terminate these. So, where is my cutter? Got one handy? I don't think I do. Okay, so I'm gonna have to grab a pair of scissors. All right, let's try that. So first off, we're just gonna lop the, so I actually put flux on these things, which obviously is not a wise idea if you want it not to smoke. So I'm just gonna cut the end of the wire, which is exceedingly difficult because it's carbon fiber. However, it is doable. Okay, so that's done. And now I'm gonna take a page out of the old military and jerry-rig playbook and just strip the wire carefully with a box cutter. Obviously, if you're doing this and you have the time, go get yourself the tools that you're supposed to use. It'll make your life a lot easier. This is, of course, just because I'm kind of in a pinch, and it's not what I would normally do if I had more time. So there we go. That little guy is ready. So is the other side. I'm going to set you down here so you can kind of see a little bit better what I'm doing. I'm going to try to illuminate it as well. Okay, so there's our two ends. And it's kind of hard to see, but they are much better looking than before. And now, if I can find the splice that I grabbed, yep, there it is. Okay, so the major issue with this, cutting them in half, in fact, I might even, yeah, so that fits in there just fine. But the other way around, it has a narrower opening because of the cut. So I'm just kind of finessing it on here by twisting it as I insert the wire. Yeah, it doesn't look like it's going to work. Let me try the other side because it might have a little bit larger opening. Let's see. It is indeed fitting. Okay, so that works. And now, getting this together, let me see if I can give you a little bit of a better view here. There we go. Okay. So these two guys got to go together, right, like this. Yeah, that may not be possible, so I may have to use a different splice and not cut one in half. Yeah, so that's what's going to happen. Okay, and it's mainly because they are really, really difficult. They're not like metal wires where you can mesh them together and they'll stay there. The carbon fiber, anyone who's worked with carbon fiber knows this, but it's very stiff, but it's extremely, well, it's not stiff, it's flexible, but it likes to hold its well, it's a fiber. So the shape, while it doesn't hold a specific shape, it doesn't play well with the other fibers. They'll bend a lot, and because there's so many of them and they're so fine, it's really difficult to get them together. I had a really hard time doing that initially, just to test the wiring in the first place. But I learned something with this, which was essentially, maybe some of you already knew, but carbon fiber is obviously a great conductor and highly flexible, which makes it extremely an extremely good choice for heating elements in flexible materials such as a glove. So something that's, maybe obvious now, but wasn't obvious to me at the time. Now the reason I don't recommend these is mainly because when I'm gonna, you'll see when I go and crimp this thing, they have this is essentially a stripper tool. It's not actually a crimper. That was my mistake for buying it, but what'll happen is it'll press this side of the crimp down and turn it out so that it's not straight, and obviously that's not ideal. So I want to get it as straight as possible while I'm doing this. So I'm going to try my best to hold it in place. and give that wire lots of room to stay. Okay, and let's see if that worked. Nope, sure didn't. Okay. Well, that's a bummer. That means I'm going to have to try a different method for getting that thing to stay in the crimp. Let's see if I can try it again. Come on, buddy. Maybe if I might be able to get it just by going a little bit further. Sorry if I'm obstructing your view. Here we go. No, that looks like it almost cut through the end of it. Yeah, that's not ideal, but it does indeed work. So I'm going to give that a try. I'm going to put some heat shrink over one end, or over the other end. I'm going to try to do the same thing, and then I'm going to solder this in hopes that it maintains some strength. So I'm going to go ahead and plug in my soldering iron now so that it's ready to go. The trouble with that, of course, is going to be that it's a carbon fiber wire, so it may not like that very much. Okay. Where's my knife? There it is. Let me cut this guy. There we go. Cool. Right on. Now this should be somewhat interesting. As I mentioned before, it's the heat shrink is not exactly the correct size, so it may or may not satisfy this requirement. I'm going to try a slightly larger opening on the tool, just to see if that works a little bit better. And hopefully you can see that. Okay, that one worked a little better, as you can see. One side is nearly cut and the other is not, so I may end up just a little tug. Obviously, with something like this, climbing Everest, I'm not really looking to have extra problems. So this is oh wow, that's cute. My wife left me a little note with a label maker. That's awesome. So I'm gonna get this thing soldered together, and the next thing you'll see is gonna be me testing this with a circuit with a voltage measuring tool, and we'll see if it works with the splitter that I bought. So I went ahead and redid the splice because I wasn't happy with the way that the first one worked out. It looked like it weakened too much. This looks a lot better. I don't think I'm going to need to put any solder on it. And although the heat shrink isn't actually going to get small enough, I think, to really seal it up, I'm going to give a shot to maybe just adding either another length of wire here to hold it in place, or possibly just adding some extra material there, maybe with some of the other heat shrink, so that it sticks around and seals it up better. Right, as you can see, I've used a bit of a jacket from another wire, which is also part of this project. This is a 135 female end for a DC, usually used for 7.4 volt jack, because obviously for heated gloves, that's what this uses. And between these two, I couldn't find for the life of me a splitter that went from USB-C to two 135s, but I was able to find this one, and it's really hard to tell, but one of these is, I think a 4017 is what this one is. And it's just basically a slightly different standard that's apparently used more for heated jackets than gloves. So it fits in here. I'm using this dongle to modify that cable, and we're going to see how that works. But for now, using the jacket, I was able to split it and put it over this, and we're going to put the heat shrink over that, and hopefully that'll shrink up nicely and support the splice just fine. Okay, I've still got my soldering iron going, so I'm going to unplug that now, because I can feel the heat coming off of it. But we're going to go ahead and shrink this thing with a little bit of heat. Hopefully not burning ourselves. Make sure to get both sides. Now, I don't normally recommend holding things under tension like this, but this is also a way for me to double check that splice is just fine. Okay, that's probably plenty. I'm going to squish down the ends just a little bit to hopefully they'll seal a little better. But there you go. That's a completed splice. Now we're going to grab the battery pack and we're going to test this thing out. Here's the plug for the glove. We're going to plug that in and we're going to watch the readout here. So first off, you can see it shows 8.9 volts and no amps. I'm going to flip the button on, which is this guy right here. It's a press and hold. It should turn red. Yep, there it goes. And now 10 watts, 1.2 amps. So it is indeed working. I'm going to hold the glove, feel the heating element. Hopefully it is working correctly. Yeah, it's getting warmer. I can feel it. And now we can test the modes. So red is full hot. One press to white is medium hot. There it goes down to 0.8 amps. You can see the readout on the graph. All those previous graph marks are from a test with the other glove to check the splitter over here. All right, on one more press, down to blue, the lowest heat level, 3.5 watts, 0.3, almost 0.4 amps. So, and then I'm going to press and hold, and that should turn it off. Yeah, there it goes. Successful test. Okay, we've finished the incorporation of the new 35-135 connector. It's plugged into the glove. We're still showing just below 9 volts. And I'm going to flip this guy on. And it's drawing 10 watts, almost 11 watts, 1.1 amps. And I can feel nothing yet. But I did test the glove earlier, and indeed the heating element in all the areas across all the fingers and the thumb is all working, and it does actually feel like it's warming up right now. Yep. And that's on the new side. So, and I already tested the cable on the old side. So the next test, we're going to go through the levels here, is going to be with both gloves plugged in. Yeah, there's all the way down to the lowest level. And then off. Okay, so I've got both the gloves hooked up. The display is still, focus, it's still showing 8.9 volts. And I'm going to turn on one glove. That's one. And that's showing good 10 watts, 1.1 amps at just below 9 volts. We're going to turn on glove number 2. And it looks like they're both running. We're drawing 20 watts at 9 volts, 2.2 amps, which is perfect. That's exactly what we wanted. And this battery pack, let's see, is at 3.7 volts. It's a 10,000 milliamp hours, so that's probably not super great. I'll have to do the math and figure out what the duration is that it will last. But the idea is that these guys at their lowest setting should give me something on the order of 7 or so hours of heat. And the whole purpose of this is so that when I've got my larger gloves, these guys, or my mittens, if my hands get cold because I had to take them out to do something, say with my Petzl or somewhere else on my climbing gear, or maybe my headlamp, then I can stick these back into the glove and it'll keep my hands warm. I can sort of give a boost for whichever hand it is that was cold and avoid frostbite. So Yeah, pretty neat tool, this little thing. That's got to be my favorite so far. It's really helped, especially with the graphical representation, showing me what everything is drawing. I got a whole plethora of extra gear, obviously, that I'm taking with, and my solar panels over there. But yeah, so that's how you repair a heated glove element. At least the connection to it anyway, to your control device, the buttons on this, in this particular case. So don't be afraid to fix your carbon fiber wires. You can crimp them. They're not solderable, obviously. But yeah, be careful when you're doing stuff like this. Make sure that you're putting your connections together properly and they're reliable, especially with heated gear like this. That's obviously going to create a fire hazard if it's not repaired correctly. So, but don't be afraid to do it. Always give it a try whenever you're presented, and you might find yourself saving, $130 worth of replacement gloves like I just did. Well, thanks for watching. That's all for now. If you want to see something more, leave a comment in the comment section, and don't forget to like and share this video. Bye.